Add 13s on both sides.
Yes, but I prefer to focus on the
Okay.
variable first, but you're correct.
Minus
And
3x.
yes, exactly.
Yes.
So 12x minus 3x, which is
9x.
very good, less than or equal to negative 15 plus 13, which is negative 2. I am dividing both sides by 9. I will not switch the inequality symbol because 9 is not a negative number. So then I have x less than or equal to negative 2 over 9. And this is it. And when on the number line, I have negative 2 over 9, which is a full point. Less than, negative infinity, bracket. So negative infinity, negative 2 over 9 with a bracket. And this is it. You're solving it. Don't change the inequality symbol into an equal symbol. You're solving it as if, don't even look at the inequality symbol unless you divide or multiply by a negative number. You solve as you know, and then you write the integral notation. Okay, this is a good one. 2 minus x over 6 greater than 4. Okay. Like last week, Monday, we want to eliminate fractions. But it is true that it will be easier if I move to the other side first. Negative x over 6, it was positive here, it's negative here, so what do I get on the right-hand side?
Two.
Excellent. Now be very careful because I need to multiply both sides by a negative number. Which number?
Negative 1.
Negative 6. We want to eliminate the fraction. But careful, I'm multiplying both sides by a negative number. This symbol has to switch because I will multiply both sides by a negative number. So this side is x. What do I get on the other side? It's negative 6 over negative 6, which is 1. But what do I get on the other side?
Negative 12.
Exactly. And it's done. This is it. Left, right, from negative infinity to negative 12. With a parenthesis because I don't have the equal symbol. I would have put the bracket otherwise, but I don't have it, so it has to be parenthesis. Okay, one more. Okay, a truck can be rented from company A for $110 a day plus 50 cents per mile. So plan A if you want, 110 plus 50 cents times the number of miles. Let's stop for a moment before we continue. $110 per day plus 50 cents times the number of miles we drive. And now let's see plan B or the other truck company. Company B charges $30 a day plus 60 cents per mile. Okay. 30 plus 0.60 cents for each mile. Okay, let's see what they want. How many miles must be driven in a day to make the rental cost for company A a better deal than company B? What does it mean when we pay for something? Company A or plan A better for us than plan B when we pay, not when we are paid. We have to pay for something. We have to pay for the rental. And we say plan A was better for us than plan B. What does it mean? What is the inequality symbol between A and B? We want to pay. Or we need to pay. We hope not. So if I want this to be a better deal when we pay than this one, what is the inequality symbol between A and B?
Less than?
Yes, because we want to pay less. That's a better deal. Now, if we want to be paid, then true, A will be greater than B. Okay, I only have to replace the plans. I replace A by 110 plus 0.5x less than 30 plus 0.60x. Exactly what we just did before. So we move this to this side and we move this to the other side. I prefer the variable on the left, but it doesn't matter really. You can do the other way around. So 0.5x minus 0.6x. 0.5x minus 0.6x.
Point 1x.
Minus 0.1x less than 30 minus 110. 30 minus 110.
80.
Perfect. Careful now. We have to divide both sides by which number?
.1.
Negative.
Yes,
Negative 0.1.
by negative 0.1. What do we need to do ever, ever, ever? Forever. Always.
You gotta flip the equality sign.
Exactly. So x is negative 80 over negative 0.1. This is 800 miles. So we will pay less, and we should choose plan A only if we know that we are going to drive more than 800 miles. If we drive less than 800 miles, this is a better plan for us. We're going to end up paying less. But if we know that we have to drive at least 800 miles, this is a better plan. We will pay less with this plan than with this. For company A to have a better deal, the truck must be driven more than 800 miles. Okay? Now, finally, I want to get to something called, this is the last section, although as I mentioned, I skipped one section. And I'll explain in a minute. Let's complete this one. And compound and absolute value inequalities. Compound and absolute value inequalities. This is slightly more involving than just simple linear inequalities. Let's see. Okay. We want to solve this inequality. This is called compound. Doesn't have absolute value in it, right? It's compound inequality first. So the inequality is negative 7 less than 3x minus 4 less than or equal to 5. Okay. So why is it called compound? Because as you see, there are two inequalities here combined or in a chain. I like to call them a chain. Chain inequality. So I have an inequality which is this, and I have an inequality that is this. But when it's a chain, I want to solve the compound as is. I'm not going to separate them. Separating them is not a good idea. So I still want to solve for x. This is my target. This is what I'm trying to solve for, right? Assuming you just have one side, how will you solve this inequality for x? What will be our first step?
Add 4.
Of course, but I will add 4 to all 3 sides, not just to one side. I will add 4 to the left, I will add 4 in the middle, and I will add 4 to the right. Let's see what happens next. So, -7 plus 4. Anyone?
-3.
Excellent. These will go away. So the middle is only 3x. 5 plus 4.
9.
Excellent. What will you divide all 3 sides by to get x alone in the middle? Isolate x in the middle.
Would be +3.
Exactly. -3 divided by 3 is -1. 3x divided by 3 is x. 9 divided by 3 is 3. Done. All you have to write is the interval notation. Parenthesis for -1, comma, 3 with the bracket. This is how we solve compound inequalities. The absolute value are a little bit more involving. But this is how we solve compound inequalities. Let's look at more. Here's another. Very good. -3 less than 2x plus 1 less than or equal to 9. First step, please. What will you do?
Divide. Subtract 1.
Yes, the weakest link first. Subtract 1. Subtract 1, subtract 1, subtract 1. What do we get?
-4.
Excellent. Less than, not less than or equal to, 2x less than or equal to,
-9.
we have to do the same thing to all 3 sides.
8.
Exactly. So this minus this is -4, 2x plus 1 minus 1 is 2x, 9 minus 1 is 8. What will I divide all 3 sides by to solve for x in the middle?
2.
Exactly. -4 divided by 2 is -2. 2x divided by 2 is x. 8 divided by 2 is 4. That's it. Done. Very simple. Parenthesis for -2, comma, bracket for 4. Okay, now this is a different story with the or. Now, let me just explain. How do I read such an inequality? This is an inequality using and. We're going to talk about an inequality using or in a minute. But what does this mean? Here's how I read it. 2x plus 1 is greater than -3, and at the same time, less than or equal to 9. That's an and. And we solve it as a chain. And we will always get an answer like this. Maybe parenthesis, 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 bracket, maybe bracket, parenthesis, or bracket, bracket. It doesn't matter. The and, or the chain if you want, will always look like this. Now what does this or mean? Okay, so let me give you another example of the and. I will say to you, I will go to the beach if Christina and Michaela are coming with me. And Very strong. I will not go otherwise. So I will go to the beach if Christina and Michaela are coming with me. This is more relaxed. I will go to the beach if Christina or Michaela are coming with me. If both of them want to, that's fine too. But I'm happy with either one. This is a very strong relationship. It's and. It's not going to happen unless this and this happens. But this one is more relaxed. Okay, if one of them comes with me, I'll go. Okay? So let's look at examples with or. And you'll see where the or is coming from and where the and is coming from when we discuss the absolute value. So solve the compound inequality. The compound inequality with or and x less than 8. Okay. Also, the mathematical symbol for or is union. Union. So when we write the solution for an or, we may have to use the or symbol in mathematics, which is the union symbol, which is the regular U, uppercase U. Okay. So I'm going to write it here. So which page am I on? 14. Okay. On the real line, because there is nothing to solve. This is solved, this is solved. They're starting us with a very simple example. X greater than or equal to 9. 9 is here with a full point, greater than, bracket, to the right. Let's see the other one. Well, 8 is here. So this was 9 and this is 8. And this one says less than 8. Okay. I have nothing to write, nothing to do. This is solved, but I have to use the union symbol. So the solution for this is exactly what you see. From negative infinity to 8, of course with parenthesis, union 9 to infinity, bracket 9 to infinity. This is it. So what does this mean? It means that this compound inequality is true, very relaxed, if I pick x here or if I pick x here. If one of these two is true, then so is the entire compound inequality. Relaxed. This is not always the case. You will see. Okay, so let's take a look at another. Here's another or situation. The union symbol may be required for the or situation. So I'm copying it. 3x plus 3 less than or equal to 6, or 3x minus 7 greater than or equal to 11. Now this requires work because the inequalities are not solved. So this is the statement. So I have to start on the side. I cannot look at both. This is not a chain. These are separate inequalities. How do I solve the first one? What should I do first? This we know, because this is simple. What will I do first in here to solve for x?
Minus 3 on those sides?
Of course, because I'm moving 3 to the other side. Oops. Good. And then I divide both sides by Then I divide both sides by
3.
perfect to get 1. This is done. Now I have to move to this one. So I have 3x greater than or equal to greater than or equal to
18.
yes, indeed. So x greater than or equal to?
6.
Excellent. Now these two are solved. Now I'm ready to put them on the number line or real line. Okay, x less than or equal to 1. Bracket, negative infinity to 1. This one says 6 to infinity. Bracket. How do I write the solution? Exactly how we wrote it before. Can anyone tell us? Anyone, please? It's exactly what you see here with the union symbol. Nothing else.
Negative infinity.
Sure.
1.
To 1 with a bracket, union, bracket.
6 infinity.
That's it. Done. Perfect. Now we're getting into absolute value inequalities, and I need to explain the theory behind it. Again, this is a portion that is not trivial, so please pay attention. There are two possibilities. The absolute value of x to be less than or equal to a number. I'm going to call that number p. This is one type of absolute value inequality. And there is another. The absolute value of x greater than or equal to p. Of course, it can be just less, it can be just greater than, but I put the whole thing in there. So there are two types. Well, this one is an and this one is an or. So expect the answer for this one to be like this, and expect the answer for this one to be a chain, because it's an and. The or is this one. Obviously more difficult because they are two separate inequalities and I have to write that union thing. So once we understand the and the chain and how these translate, then it's going to be easy. But we have to understand the translation first. Okay, so let's start with an and. So type 1, this one. This is not a difficult one. Let's say a simple example. The absolute value of x is less than or equal to 3. This is replaced by, we cannot solve this. We have to replace it by its equivalent, compound and compound inequality. Negative 3 less than or equal to x less than or equal to 3. That's it. So the general solution is negative p less than or equal to x less than or equal to p. Of course, this is a simple example. There will be more involved. That's it. So the answer is negative 3, 3. So let's practice this one, this type.